Yeah, so anyway, recording has started. Any questions, any doubts, any difficulties with these 4 problems that we talked about last time? Any answers, anybody? Anybody stuck in any of these 4? Should we see the solution or can we go to the next problem?
So
Yeah,
the RH percentage for the first one is 51.4%.
okay. Let me write that. 51.4%,
Dew point is 32.67.
32.7, and humidity
0.0318.
in kgs, right?
Yes, sir.
Okay. Anybody else? Any other answer?
So the same answer, sir.
Sir, same answer.
Yeah. So
Same
any,
answer, sir.
shall we take it that this problem there is no doubt we need to solve? Do we need to solve or shall we go to the next one? Next one, is there any doubt? Anybody stuck anywhere? Anybody stuck in the second problem?
No, sir.
How did you do? Can you tell us? Would you like to tell us how did you do?
So
Yeah.
the first one or the second one?
Second one. First one, there is no problem, right? Nobody is asking any questions. Second one,
Okay. For the second one, the temperature of the wet bulb is given
right?
and the dew point is given.
Right.
So we first find out the vapor pressure at 20 degrees Celsius and
Correct.
30 degrees Celsius. Then
Okay.
we write the equation for uh, humidity near the surrounding of the wet bulb, near vicinity.
Wait a second. Wait a second. Vapor pressure at 20 degrees centigrade. How much is that?
17.35 mmHg.
17.35 mmHg. Okay. Now, so that means the partial pressure of water vapor in the air must be equal to the water pressure
17.3.
at 20 degrees centigrade. So this must be the partial pressure uh, of water vapor in the air because that's corresponding to dew point. So from this we can get the humidity of the air. Humidity would be 17.35 divided by total pressure. Let's say 760 everywhere. 17.35 multiplied by 18 divided by 28.84. Somebody tell me this number.
0.0146.
0.0146. Okay. Now how did you get?
Uh, then we calculate humidity near the vicinity of the wet bulb.
Right, so that is based on this wet bulb temperature. So corresponding to this wet bulb temperature, you calculated vapor pressure at 30 degrees centigrade. How much was that?
That is 31.65 mmHg.
31.65 mmHg. Then from this vapor pressure, you calculated the humidity at the wet bulb condition near that wet cloth of that wet bulb. So that will be 31.65 divided by 760 minus 31.65 into 18 divided by 28.84. Right. How much is this number?
0.0271.
0.271 kgs of water vapor per kg of dry air. Okay, next, what did you do?
Then we use the equation. Uh,
Right. So using these two, we know that humidity at the wet bulb temperature minus the humidity would be equal to Cp of dry air plus H times Cp of water vapor divided by lambda T minus T wet bulb temperature. So here now we know everything. We know the wet bulb humidity. We know the humidity of the air. CP air we know. Humidity we know. CP water vapor we know. Lambda is something that we don't know, or do we know?
So we can calculate.
Yeah, correct. Lambda is based on the wet bulb temperature. That is, wet bulb temperature is known. Lambda, I told you last time, lambda was 540 plus 0.55, 100 minus T. That temperature is the temperature at which water is evaporating. Water is evaporating at the temperature of the wet bulb, and therefore this is the wet bulb temperature. So lambda also we know, and the wet bulb temperature we know. So the only unknown is temperature, right? So then we find the temperature. Okay, so what is the temperature now?
the temperature comes out to be 59.3 degrees centigrade,
Okay, 59.3 degrees centigrade.
and
Now it is
we
straightforward.
calculate
Once you calculate temperature at 59.3 degrees centigrade, we can calculate vapor pressure at 59.3 degrees centigrade. How much is that?
144.65.
144.65 mmHg. Oops, mmHg. Now percent RH is based on this vapor pressure, because that is what the maximum amount of water vapor air can hold, because air is at a temperature of 59.3, whereas the actual partial pressure of water vapor in the air is 17.35. So percent RH would be 17.35 divided by 144.65 into 100, right? Straightforward. Okay, somebody else wants to tell me the third problem. Somebody else. Have people done the third problem?
Yes, sir.
Okay.
Yes, sir.
Okay. Let us see. Somebody would like to tell me how they did the third problem. Let's say, let's take some names. Let's see. Uh, whom should we call? Any volunteers for the third problem? Ram, are you there? Uh, Ram has left the meeting. Is it by mistake or by design? Ram, are you there?
Yes, sir. Yes, sir.
Have you had your breakfast now?
No, sir, not yet.
Not yet. Are bapre. Mm, okay.
No, no, but I'll have it
No,
after the
no,
class.
you can have it parallelly also. There's no problem. Have you done the third problem?
Yes, sir. I have tried, but I got one equation, but I
Uh,
couldn't mind solve that equation.
okay. So would you like to tell us how you solved?
Yes, sir.
Wait a second. Let me rub all these things. Let me just select everything and then I can delete everything. Yes. Right. Tell us. Third problem. What is the third
Um,
problem? Third problem says that wet bulb temperature is 20 degrees centigrade. RH is 50%. We want to find the temperature. We want to find the dew point. Want to find the humidity. Okay.
yes.
Tell us.
So first we know that percent RH is 50%. So formula for percent RH is partial pressure of water vapor at dew point temperature upon vapor pressure at temperature of air into 100.
Okay. Okay, but we don't know anything. We don't know either.
Yeah, so we can take variables, sir.
Okay. X and Y, or what do you want to take? Or tell me some. Tell me how you have solved, or how you
Uh,
have attempted to solve.
I took partial pressure of water vapor as x and vapor pressure at
Okay, so assume partial pressure of water vapor is equal to x. Okay, now
and vapor pressure at temperature of air as y.
okay,
Then
so
we
then
can write
we know that x by y into 100 is equal to
is equals
50.
to 50.
So that
Yes,
means x by y is equal to 0.5. That means y must be equal to 2x. Y must
y
be
is
equal to
equals to 2x.
2x. Okay,
Yes.
right.
Then I
So we can straight away substitute this so that we don't keep on having so many variables.
yes sir.
Okay, now
Then I calculated wet bulb humidity
okay, so you calculated based on the temperature of the wet bulb at 20 degrees centigrade. You calculated vapor pressure at 20 degrees centigrade. How much was that?
17.5.
17.5 mmHg. And then you calculated the humidity at the wet bulb as 17.5 divided by 760 minus 17.5 into 18 divided by 28.84. How much is that?
0.0147.
0.0147. So kgs of water vapor per kg of dry air. Okay, now
Yes sir. Then I calculated humidity at temperature of air.
how
I
did you
took
calculate that?
I took variables.
So in terms of,
So
we already know that vapor pressure is
yes,
2x
yes,
and partial pressure is x. So correspondingly, humidity of the air would be x divided by 760 minus x into 18 divided by 28.84.
84.
Is that right?
Uh, yes, sir.
I mean, is that what you calculated, or I'm just writing
No, no,
something?
no. That's correct. I took this
Okay,
variable.
okay,
Uh, then I calculated lambda WB
okay. So lambda WB is 540 plus 0.55, 100
into
minus the wet bulb temperature, and wet bulb temperature is 20 degrees centigrade.
20.
So
Yes, sir.
100 minus 20. So lambda is how much?
Uh, 584.
584. Okay. Units kilocalories per kg. Pay attention to units.
Yes, sir.
Okay,
Uh,
next.
then I substituted everything in the main formula,
So
which
now your
is
formula is for the wet bulb temperature, Cp of dry air plus H times Cp of water vapor divided by lambda T minus the wet bulb temperature, right?
yes, sir.
So HWB is so 0.0147, right? This is HWB. Humidity is X divided by 760 minus X into 18 divided by 28.84. That is your humidity, right? So 0.24 plus H humidity X divided by 760 minus X into 18 divided by 28.84 multiplied by 0.45 divided by 584. Okay, temperature.
So we
So
have relation between temperature and vapor pressure, so we can
ah
write temperature in terms of vapor pressure.
so now if this your vapor pressure or partial pressure is X, or vapor pressure uh, of the
2x,
temperature
2x.
is 2x. So now you are going to say that ln Vp is equal to 18.3036 minus 3816.44 divided by T minus 46.13, and temperature is in Kelvin, right? So be careful, because this wet bulb temperature we are taking in degrees centigrade,
Yes, sir.
isn't it? So, but this temperature, if we are using this temperature here, then that temperature we are using in Kelvin. So be very careful. Uh, we want it in degrees centigrade. So what we are going to do is we are going to rewrite all this, and ln Vp is, now we know that it is 2x, right?
Yes, sir.
So ln 2x is equal to this whole thing. So if you write everything in terms of temperature, T, let me write it slowly and let me write it properly so that we don't make any mistakes. ln2x is equal to 18.3036 minus 381644 divided by t minus 46.13. So 18.3036 minus ln of 2x, right, would be 3816.44 divided by t minus 46.13, or t minus 46.13 would be equal to 3816.44 divided by 18.3036 minus ln 2x. We can bring that 46.13 on the other side. Right, and this would be temperature in Kelvin. If I want it in degrees centigrade, because this temperature is in degrees centigrade, wet bulb temperature I've given is in degrees centigrade, or you can convert that into Kelvin, whichever way you like. You can say minus 273.15. So now I can put that here, 46.13 plus 3816.44 divided by 18.3036 minus ln 2x minus 273.15 minus the wet bulb temperature. Wet bulb temperature was 20 degrees centigrade. We get this huge mammoth equation. Is that what you got?
Yes, sir.
Now, what is the answer? What is
No,
x
sir.
equal
That
to?
equation I couldn't solve.
Why you couldn't solve? First year you've done Newton-Raphson method, isn't it?
Sir, I used calculator, but I didn't thought of that method.
Calculator also will give you the answer. Why not? Suppose calculator is there or not there. What do you do? I mean, is there a good way to start? Is there a good guess value?
Mm,
Anyway, calculator is going to do Newton-Raphson only. So what is a good guess value to start with?
Greater than 20, no?
Yeah, what is our x? X is our partial pressure of water vapor in the x. Obviously, you can take uh, x to be something more than vapor pressure at 20 degrees centigrade, maybe double of that or something like that. You can just take some guess value. But calculators, yes, calculator will give you an answer. Only thing is you will have to make sure that you give a good guess value. Only then it will nicely converge, because there is a log, and there are linear terms and there are log terms. So it is a highly nonlinear equation.
So can we use a graphic calculator?
Yeah, you can use a graphic calculator. Sure. So you are going to plot
So sir,
left hand side and
we
right
get
hand side as function of x, right?
yeah. So actually, what I did was I directly substituted the Antoine equation in x, and
Hmm.
then it became a function of t completely. So
Correct. Here also it is function of x completely.
yes, sir.
So
Uh,
either you, whatever way you do, you assume temperature as x, or you assume vapor pressure as unknown. It is one and the same thing. You'll have to have Antoine equation somewhere coming.
so from the
Sir,
Yeah, yeah. Go ahead. Go ahead. One
sir,
second, Praveen. Just one
sir,
second. Let Arya complete. Then you can say.
so I got temperature as 51.85 degrees.
Okay.
Partial pressure at that temperature was 50.655, 50.66 mmHg.
So your x was 50.6.
Yes, 50.66.
Here x is the partial pressure of water vapor in the air.
Yes, sir.
Okay.
So vapor pressure would be 101.32,
And temperature was 50,
1.85.
51.85. Okay. So once you have temperature, once you have partial pressure of water vapor, you basically have everything,
Yes, sir.
right? Praveen, you were saying something.
Sir, I didn't use the Newton-Raphson. I used the general iteration method, and I didn't get
General
the
iteration
temperature.
method means what? What do you mean by
Sir, it
general
is
iteration
it
method?
is also a kind of Newton-Raphson, but different
No, no. You tell me
form.
what that general iteration method means.
Sir, means that you make a equation for use of iteration. So there is a formula, but in general iteration, we ourselves make that formula.
No, no, I have not understood anything. You got this equation. Now tell
Yes,
me
sir.
how you have solved.
Sir, I have simplified it
Okay.
and then made it.
Simplified it to what? What is the simplified equation?
Sir, wait a minute. Um,
There's no such thing as general iteration formula.
sir, maybe my terminology is wrong, maybe,
Huh.
but sir, but I didn't get the temperature so high. I got it 27.6.
27.6.
Yes, sir. Even I got 27.5.
Yes, sir. I also got same.
Okay. 27.6. All right. That is one more possibility, either 51.8 or 27.6. Okay. So Praveen, you are telling us how you solved.
Yes, it's slightly also complicated, sir.
Anyway, you can do it on your calculators. Calculators do Newton-Raphson anyway. So uh, anybody else? So Ram, have you tried it solving on a calculator now?
So my answer would be wrong, I guess.
No, no, we don't know whether your answer is wrong or whether this 27.6 is wrong.
No, sir. Like I can say because the partial pressure that I've got is 50.6 mm Hg,
Hmm.
and the dew point would be corresponding to this, which is higher than 20 degrees Celsius. So
Ah,
obviously,
that's why you think this is wrong.
yeah.
Okay. But then you check now what mistake have you made? Maybe some calculation mistake somewhere.
Yes, sir.
Just check that. So Ram, have you got the answer now from the equation? Did you put it in the calculator?
No, sir. No, sir. I'll
Do it now. We are waiting for you. Any other answer anybody has got? Some people have got 27.6 degrees centigrade as the answer. Any other answer?
Yes, sir. Even my answer matches with Praveen.
Now it is 27.6. Okay. Anybody else has got any other answer? Anybody has doubts? Ruchita, are you comfortable?
Yes, sir.
Did you get the answer?
Yes, sir.
27.6 or some other answer?
Oh, 27.6.
Okay. Saurabh,
Sir, I got 31.5, sir.
31.5. Okay. But did you follow what Ram was
Sir, I
saying
got
about?
31.
Yeah, yeah, I understood you got 31 point something. Uh, have you understood what Ram was doing? Did you follow what was being written on the board, or you had some other method to solve?
Yes, sir.
Which
Yes, sir, I
method
was
you?
following, sir. No, sir, no, sir. Same method, sir.
Saurabh, I can hardly hear you. Speak loudly.
Sir, that X by Y, sir.
X by Y. Which? What is X? What is Y? Was your method same, or you had some other assumptions? You had some other unknowns?
The same method, sir, that
Same.
Ram used.
Okay, same method. But then why answer is different? Is
Yes,
it
sir.
by solving or some
Yes,
error
sir.
you have
Yes,
made?
by the.
Just check your calculations.
No, sir. No, sir. I also take that. Yes, sir. Yes, sir.
So check your calculations.
Sir. Yes, sir. Calculation mistake, sir.
No, you check. It may not be calculation mistake. You might be correct.
Yes, sir. Yes, sir.
27.6 may be wrong. I don't know. I don't know the answer.
Yes,
Snehal,
sir. I will check, sir.
Snehal. Oh, there are two Snehals. Snehal Patil.
Yes, sir.
Did you get the answer?
So actually I stopped where now I understand how to solve.
You have now understood?
Yes, sir.
Okay, fine. Shall we go ahead?
Yes, sir.
So perhaps answer is 27.6. Perhaps answer is 31.5. I don't know. You people solve. You find out which is correct, which is wrong. Okay. Next, last problem. This problem. Can we solve this? Anybody has solved? Any answers?
Yes, sir.
Arya, wait. Let other people say something. Otherwise, I have to pick on people. Some other volunteers. Swaroop, you are going to volunteer.
Yes, sir.
Answers you got, or you are getting, or you are solved, anywhere you are stuck.
I got percentage RH and H.
Wait, let me write. So you got h equal to what? What was your answer?
0.0146.
0.0146. Okay. Percent RH you got what?
31.43.
31.4. Okay. And wet bulb temperature?
It did not work.
Did not get. Why not? You were stuck somewhere, Swaroop? You got stuck somewhere, or what? Why you did not get? I mean,
Equation become complicated.
you got the equation, but you
Uh,
got the complicated equation. Okay. So you were
just
stuck at
like,
solving the equation, just like this previous problem.
yes, sir.
Okay, but now did you try using calculator, Swaroop? Or how did
Yes,
you use? You could have used graphs, graphical method also. You could have used. You could use Excel. Have you tried using Excel? In Excel, there is function. Should I show how to solve using Excel?
yes,
Either you can plot graphs of left hand side and right hand side, and um, check that your when the two graphs intersect. That can be one way of solving. Or in Excel, mm, there is a there is a function called as solver and goal seek. I don't know. Suppose we want to solve this equation: x square minus 5x plus 6 is equal to 0. So that is the equation. Suppose I want to solve. So what are the roots? Obviously, we know that x equal to 3 is a root and x equal to 2 is a root, right? Swaroop,
hello,
Swaroop, are you there?
yes, sir. Hello,
Let me share. Yeah, I'm able to hear you, Swaroop. Are you able to see the screen?
yes,
Swaroop, are you there?
yes, sir.
So suppose, Swaroop, we want to solve x square minus 5x plus 6 is equal to 0.
Yes,
Obviously, we know the roots are x equal to 3 and x equal to 2,
Yes, sir.
right? So you can
Yes.
give a guess value of x. So your guess value of x is, suppose, say 5.5. Okay. Then you can write your equation in terms of this x value. So that is x square minus 5 times x plus 6. So that is the value of your left hand side. Now you want your left hand side to be equal to 0. So there is a function called as goal seek. So there is a function called as goal seek. So what you're doing is you are telling Excel that you want the cell number C8 to be equal to value 0 by changing your cell B8, right? And then it should solve. See, it has solved. It has made the value almost 0, and the answer is 3. Right? If you start with some other guess, let's say 0.5. Now again, if you want to do goal seek, you can do C8 to be value 0 by changing cell B8, and now it will give a value 1.9995, that is 2. Right? So Swaroop, will you try using Excel?
Sir, I don't have PC.
But Microsoft, you can on your mobile, perhaps there's a
So
Microsoft app.
we can use Desmos as a graphic calculator also.
Yeah, you can
In
use
that,
Desmos also as a graphic calculator where you can plot graphs. Uh, that is also possible. Uh, so, but will you able to solve? Will you able to solve now, Swaroop? Will you try? Use
Yes.
Newton-Raphson.
Yes.
Okay. Anybody has got any other answer for this? Should we just quickly see the solution? So dew point temperature is 20 degrees centigrade. That means partial pressure of water vapor in the air must be equal to the vapor pressure at 20 degrees centigrade, right? So we can get this partial pressure. Now getting the partial pressure, we can get humidity, right? This also we can get, and temperature we know, so we can find out the vapor pressure at 40 degrees centigrade. Now we know partial pressure, we know vapor pressure, so we can get percent RH. Okay. Now humidity is known, so our equation is HWB, HWB minus H would be equal to 0.24 plus H times Cp of water vapor, that is 0.45, lambda 540 plus 0.55, 100 minus the wet bulb temperature. Now this wet bulb temperature is in degrees centigrade, right? And T minus T wet bulb temperature, right? So what do I know from here? I know the value of humidity, H I know, T I know. I don't know TW. So TW is unknown, right? And because TW is unknown, our HWB also is unknown. But corresponding to TWB and HWB, there is a relationship. What is the relationship? Based on TWB, you can calculate vapor pressure at TWB, and vapor pressure at the wet bulb temperature will allow you to write an expression for HWB. So your equation will just become that much more complicated. It will have a e raised to something term. So you just have to substitute that expression here and solve for the wet bulb temperature, right? So this equation you will have, and you will have to solve for the wet bulb temperature. Okay. Now, any other doubt? Any other question? So there are two different ways in which we can find out the humidity of the air. One way is to find the dry bulb temperature and the dew point temperature. So how to measure the humidity? One is to measure the dry bulb temperature and the dew point temperature. That is one way. And second way is to find the dry bulb temperature and the wet bulb temperature. Both will allow you to calculate humidity of the air. So these are the two ways in which we find out the humidity of air or humidity of any gas, for example. Okay, shall we go ahead? Shall we go ahead?
So,
Yeah.
like, is there any other method by if we can bypass this complex equation?
I mean, what do you wish? You wish some magic formula to be given to you so that
No, sir,
then
not a magic formula, but
uh,
where I can not get an exponential term and a polynomial term together. Like,
but is it in your hand?
No,
You're
sir.
you're stuck with vapor pressure. Vapor pressure is an exponential relationship. Log vapor pressure is related to 1 by temperature, so that's an exponential relationship. And this humidity equation is based on heat and mass transfer. So our this equation is based on heat and mass transfer, and your humidity at the wet bulb conditions at the wet bulb temperature are related by Antoine equation. So unless my Antoine equation is something simpler, there is no other way.
okay, sir,
And Antoine equation will always be exponential.
understood, sir.
Okay. Okay. Any other point? Okay. How many of you have Excel open just now? Can you open Excel? How many of you are using computer right now so you can use Excel? Yeah, Arya, you have raised a hand. Yeah, Saket, go ahead. What is it that you want to ask? Arya, go ahead. Yeah, Arya, you want to ask something?
No, sir, like I could use Excel. That's what I was trying
Yeah.
to.
Okay. Any other people are using computers just now? How many of you are using computer just now? How many of you are using mobile just now? Do we have Excel? Do you have Excel? So next, what we want to do? Yeah, just don't raise hand. Yeah, fine. What we will try to do is perhaps we will try to um, we'll see some calculations, and those of you who have Excel can do these calculations in Excel. Okay, but let us just see what we are going to do. So let me just open a new page. So what we are going to do is, by now you must have been bored and tired of solving your Antoine equation, either given vapor pressure finding temperature, or given temperature finding the vapor pressure. You have done it so many times, right? You must have got bored of this. Have you got bored of this? No? Yes? Nobody's got bored? Excellent. Okay, what we are going to do is we are going to plot a graph. All right. The graph we are going to plot is on y-axis. We are going to plot something, and on x-axis we are going to plot temperature in degrees centigrade. Okay, so we are going to take different values of temperature, say 5 degrees centigrade, uh, say 5 degrees centigrade, 10 degrees centigrade. 15 degrees centigrade, 20 degrees centigrade, 25 degrees centigrade, 30 degrees centigrade, 35 degrees centigrade, right? Like this, we are going to plot a graph, and we are going to plot vapor pressure based on this Antoine equation, right? So what we'll do is we will find vapor pressure at 5 degrees centigrade, plot that point. So y-axis, we are going to plot vapor pressure. Okay, 10 degrees centigrade, use the Antoine equation, plot that point. 15 degrees centigrade, use the Antoine equation, plot that point. 20 degrees centigrade, use the vapor pressure, calculate the Antoine equation, plot that point. 25 degrees centigrade, we are going to plot that point. 30 degrees centigrade, we are going to plot that point. 35 degrees centigrade, we are going to plot that point. Is that okay? Is everybody understanding what we are doing? We are just trying to plot a graph, and then we are going to join these points by a nice line. So this line is going to tell us the vapor pressure. So anytime you have a temperature, you can just read from the graph, or anytime you know the vapor pressure in mmHg, we can calculate, and we can go to the y-axis, we can find out what is the vapor pressure, and then we can correspondingly find what is the temperature. So that's the use of this kind of graph. Okay, now let's go forward. Rather than plotting vapor pressure, can I plot partial pressure of water vapor in the air? But then I have to give you the percent RH. So this line that we have drawn, it is based on vapor pressure. So what is the percent RH corresponding to this value, corresponding to this line?
100%.
Correct. This whole line corresponds to 100% RH. Now suppose I have 50% RH, then I will, suppose I want to find out partial pressure at 10 degrees centigrade. Suppose I want to find out partial pressure at 10 degrees centigrade. 10 degrees centigrade, I will find vapor pressure. That is this value. I'll take 50% of that, and then I will plot that point. Same way, 15 degrees centigrade, I will find the vapor pressure. I will take 50% of that and plot that point. 20 degrees centigrade, I will find the vapor pressure. I will take 50% of that and plot that point. 25 degrees centigrade, vapor pressure, 50% of that. 30 degrees centigrade, vapor pressure, 50% of that. 35 degrees centigrade, vapor pressure, 50% of that. And I join these points. So this line is going to correspond to 50% RH. Okay. Same way I can do for, let's say, 70% RH. I can do for 80% RH. I can do for 30% RH. Do you agree?
Yes, sir.
10%
So
RH. Maybe I can plot for 5% RH. Okay. Obviously, my graph is not to scale. That means this number divided by this number obviously is not 5%, but just by looking you can tell, but I'm just drawing a very qualitative graph. So now, just excuse me for a minute. Yeah, sorry. Now, rather than plotting partial pressure, we don't want to find or plot partial pressure. We would rather plot humidity in terms of kgs of water vapor per kg of dry air. So what we will do is we will not plot points corresponding to partial pressure. We will not plot points corresponding to vapor pressure. What we will do is every point we will convert into humidity and then plot. So for example, at 5 degrees centigrade, we will calculate vapor pressure. We will do vapor pressure divided by 760 minus vapor pressure into 18 divided by 28.84 and plot that point. Is that okay? 10 degrees centigrade, we will find out the vapor pressure from Antoine equation. We will convert that point, that vapor pressure, into humidity and plot that point. Similarly, 15 degrees centigrade will convert to humidity and plot. 20 degrees centigrade will convert to humidity and plot. 25 degrees centigrade will convert to humidity and plot. 30 degrees centigrade will convert to humidity and plot. 35 degrees centigrade will convert to humidity and plot. And these are going to correspond to 100% RH. So now we have a points which are in terms of humidity and temperature, but for 100% RH, right? And then we can take different percent RH. Suppose I am on percent RH of 50%. So I will take at 10 degrees centigrade, I will find out the vapor pressure. I will convert that into partial pressure, say 50% RH. So half of vapor pressure, then convert that into humidity and plot that point. Okay. Same we plot the 15 degree centigrade point, 20 degree centigrade point, 25 degree centigrade point, 30 degree centigrade point, 35 degree centigrade point, and join all those points. So then all these points will be having 50% RH, but they are plotted in terms of temperature and humidity. Do you understand? Yes or no?
Yes, sir.
So shall we do this now? 90% RH, 80% RH. Shall we do it in Excel? 70% RH. Do you want to do it in Excel now?
Yes, sir.
So do that. Open Excel, do these calculations. I will also open. Actually, I've done it already, but and this is because we are plotting in terms of humidity. This is corresponding to a total pressure of 760 mmHg. Suppose the total pressure is something different, then obviously the humidity relationship, vapor pressure humidity relationship will be something different. That's all. Okay, so just do this now. Use Excel. Is everybody clear what is to be done? Anybody is not clear what we are supposed to do? Is it clear what we are supposed to do?
So please could you repeat it once again?
Yeah, so what I'm saying is we are going to make a graph or a chart with all these calculations. So what we are going to do, let me stop presenting this. Let me start presenting our normal thing, right? For every temperature, 5, 10, 15, 20, are you able to see?
Yes, sir.
Yeah, so for every temperature, we are going to calculate vapor pressure. We are going to take different values of humidity, percent RH, calculate vapor pressure, partial pressure, convert that in terms of humidity, and plot that on a chart. Is that okay? And we're
Yes,
going to
sir.
use Excel to do these calculations and plot a graph.
Okay, sir.
Okay, so plot. I will also do it simultaneously with you. Right, so what we are going to do is we are going to take temperature in degrees centigrade, different values we are going to take. We can take as many values as I want because we are anyway doing these calculations in Excel. We are not doing it manually. Let's say we want to do it up to 40 degrees centigrade. Now suppose our percent RH is 100, right? So we are going to plot humidity in kgs of water vapor per kg of dry air. In this column, we are going to calculate that. So how will you calculate that? Corresponding to temperature, we will find out the vapor pressure. Okay, so that we will do 18.3036 minus 3816.44 divided by E is in degrees centigrade plus add 273.15. We will get it in Kelvin minus 46.13. You will get it in get the denominator and make sure we put proper brackets. So this is going to give us ln vapor pressure, right? And then we can take e raised to this number. That will give us vapor pressure. Some right. It will give us vapor pressure. So 0 degrees centigrade, 4.48 mmHg. Just make sure that I've got the brackets proper. Yeah. I can just copy and paste this formula, right? So it will tell me the vapor pressures. Now, so this is not humidity. It is vapor pressure in mmHg. And because it is relative humidity is 100%, we can also say this is partial pressure in mmHg. Right? Everybody okay so far? Are you with me?
We
Somebody?
have to take that. Sir, we have to take the temperature at a difference of 2.
No, you can take anything you like. You can take a temperature difference of 1 also, or
Yes.
0.5 also. How does it matter? That's the advantage of doing it in Excel, right? You can change everything and everything will automatically change. Happy? Now we have taken in every 1 degree centigrade. Are you happy? Or you want 0.1 degree centigrade? Rishabh,
No, sir, this is fine. Yes,
I'll
sir.
just go back to 2 degrees centigrade because it will fit nicely in the screen. We'll just go up to 40 degrees centigrade. Choice is yours. So this is now partial pressure of water vapor in the air corresponding to 100% RH. Suppose I want percent RH equal to 90. Now what will be the partial pressure of water vapor? It will be this number multiplied by 0.9, isn't it? Yes or no? Anybody there? Anybody doing something? And now all I have to do is just copy that into the rest of the cells and it will just calculate corresponding to percent RH equal to 80. Suppose I am doing, then partial pressure in mmHg would be this number, 100% RH number multiplied by 0.8, isn't it? Just copy, isn't it? Are you okay? Rishabh,
Yes, sir.
how many of us are doing? How many are doing simultaneously?
Sir, I plotted the graphs directly.
Directly means
I put the equation in the calculator. So I got the graph.
all the graphs you got, for all the partial pressures, all the RH values you got, or you got
Yes, sir.
just one?
Yes, sir.
So
For all.
can you share your screen?
Yes, sir, I'll do that.
Yeah, I've stopped
Sir,
sharing.
1 minute, sir.
Yeah, Anirudh.
how many? Yes, sir. How many values of RH are we supposed to take, sir? So, like, what percentages?
Take anything you like because we are doing in Excel. You can take
Yes,
every
sir.
1% RH also. You are not manually doing the calculations.
Yes, sir.
Understood.
So, is the screen visible?
Yeah, it is. But what are these lines for? This is what percent
Sir,
RH or what are? What is
sir,
on the
this
y-axis?
is, sir, the first green one is for 100% RH.
Mm-hmm.
The blue one is for 75% RH.
Mm-hmm.
The purple one is for 50% RH.
Okay, so what is on the y-axis? Humidity or vapor
Uh,
pressure?
vapor pressure, sir.
Okay, so you can convert that into humidity now.
So that is done in the first red line. We get this kind of graph.
Red line? No way.
The first red line. The first red
First red
line.
line means which one?
So this one.
I can't see which one you're pointing to. This
So
one.
the uh, so see, I'm showing the points.
No, how it
also.
has become negative? Humidity, how it has become negative?
So I don't know. I put the equation over here.
No, there is some problem. 18 divided by where did you do 760 minus this vapor pressure?
So I did that over here for simplicity.
No, there is some problem.
Okay.
Some problem. Just check your formula. What is plotted? How it has become negative?
Even I had that thought, sir.
So just check. So stop sharing. Has everybody got up to here? Let's say we now want. Percent RH equal to 50, percent RH equal to 30, percent RH equal to 10. We'll just do some values. We will not do all the values. So corresponding to 50, it will be the 100% RH value multiplied by 0.5. Then this number would be 100% RH multiplied by 0.3, and this number would be 100% RH value multiplied by 0.1. And then we can just simply copy and paste. It will automatically calculate everything. So now if I plot this graph, all this blue is for 100% RH, red is for 90% RH, this gray is 80% RH, yellow is 50% RH, blue is 30% RH, and this green is 10% RH. But now this is in terms of partial pressure. In terms of partial pressure. Has everybody done up to here?
Sir, how did you plot the graph once? Can you show it again?
Insert. There is a chart, XY chart. You can draw different kinds of chart, XY chart, right? Well, you select the data and you say insert chart, and it will plot the graph for you. And you can make it as a lines also. So rather than chart styles, you can make it in terms of lines also. Or if you select another chart, this is with lines, right? So it doesn't plot symbols, it plots directly the lines. So the legend also is here. This first line is corresponding to 100% RH. Second one corresponds to 90% RH. Third one corresponds to 80% RH. Next is 50% RH. Next, it is 30% RH. Next is 10% RH. Right? Now, we don't. Can we go forward?
So I
Yeah.
got the reason why it was going in negative.
Hmm.
Sir, if we go above 100 degrees Celsius, the amount of water vapor that air could handle,
Okay,
or
obviously,
air
if
could,
temperature of the air is more than 100 degrees centigrade, then water will not exist as liquid water, and then there is no point in doing these calculations if pressure is 760 mmHg.
yes, sir. So that's why it was going in negative, and the
Ah,
point was exactly at 100 degrees
okay,
Celsius.
okay, okay. So do from 0 to 40 degrees centigrade
Okay.
or 0 to 50. Everybody has got up to here, so got up to here. Now we don't want partial pressure. Suppose we want in terms of humidity. So if I want now humidity in terms of kgs of water vapor per kg of dry air, right? And we want this corresponding to 100% RH. What will that be? Now remember, total pressure is 760 mmHg, right? So I will just put that total pressure somewhere here, 760 mmHg. So how will I get the humidity? I will get the humidity from partial pressure divided by 760 minus partial pressure, right? And then this whole thing multiplied by 18 divided by 28.84. That will give us humidity at 0 degrees centigrade corresponding to 100% RH. Now if I copy this, I need to keep this cell number C1 constant, total pressure constant. So I'll just put a dollar sign here. We don't want that to change. And I copy. So now we can copy, and now we can copy to other humidities as well. So everything is automatically calculated. This is now 80% RH. Oh, sorry, 90% RH. This is 80% RH. 50% RH. RH. And this is 10% RH. Right? Automatically the formula has been copied. So these are all in terms of humidity. Right? Anybody with me? Anybody not with me? Anybody stuck somewhere? Anybody is doing in Excel? Anybody is not doing in Excel?
Yes, sir, I am doing.
Siddhant, are you doing in Excel? Siddhant Patil.
Yes, sir, I am doing Excel. I am trying, sir.
Okay, are you
I
stuck
thought,
somewhere?
sir, I am getting different values. I am checking somewhere.
Check. Shlok Mishra, are you doing in Excel?
Yes, I'm doing in Excel.
Have you got it?
Yes, I'm doing it, not stuck anywhere yet.
Shizel Wag. Shizel, are you there? Ram, have you had breakfast?
No, sir.
Are Baba, you can have parallelly. You don't have to wait till 10:30. 10:30 there'll be another lecture.
Okay, sir.
Don't skip breakfast. Otherwise you'll fall asleep. We need energy, right? Energy balance. Whatever energy you are going to get from food, that has to be used in doing calculations. Sarthak, are you doing in Excel?
So currently I'm using my mobile phone, so can't do it on Excel.
Okay, but at least see how it is being done, so we can do it later.
Okay, sir.
Sahil Khandelwal, Aniruddha, both the Aniruddhas, are you doing in Excel?
Yes, sir.
Okay, comfortable.
Yes, sir.
Now let's plot this graph as well. Let's plot this graph. Now we have plotted this graph in terms of vapor pressures, right? We have plotted this graph in terms of vapor pressures. Now we will plot this graph in terms of humidity. All I have to do is just take it to this side and automatically everything will get plotted. So now this is again 100% RH. Oops, on wrong. Yeah, this is 90% RH. How easy it is to do calculations in Excel. You can just click and drag the formula. You can plot a graph and you can change, and everything will change automatically. I can change the scale.
Sir, can you show how did you change once?
How did I change what?
The graph, you same graph you changed. How it was?
Yeah, so just copy this graph into somewhere else. So what I did, just selected the graph. So it is highlighting, no? This blue first column, A column is highlighted. That is our x-axis. These things are highlighted. Do you see them in a blue rectangle?
Yes, sir.
So you just hit anywhere on that blue rectangle and you drag it to wherever you want it to plot. So now it is plotted in terms of vapor pressure. Okay, I just took that blue rectangle and I just dragged that blue rectangle into the humidity values. So it just plotted in terms of the humidity values. Is that okay?
Yes, sir.
So this is the chart. I can change the x-axis, just make it look better. In the y-axis, just make that also look better. All right, now do you see the, no, okay, I'll just wait for some people to finish. Oops.
Sir,
Yeah.
I had a doubt, sir.
Yeah.
After plotting the graph, sir, like
Hmm.
when we need to find the value of vapor pressure or the humidity for a particular x value,
Hmm.
how do we use the graph on Excel? Like,
No,
is
you
there
can't
any
use.
option to
No, there's no option. If you are doing it in Excel, you have the formula with you, so straight away you can do it.
use the same? Yes, sir. Okay.
Right. So it says, suppose for example, you want to find out corresponding to 100% RH, when is the partial pressure going to be equal to 35. So we know that it is 31 here and 35 here and 39 here. So 30, 32 and 34. You already know it is going to be around 32. Or you can use goal
Okay.
seek, that you want
Oh,
this
yes, sir.
value. You want this value, to be 48 by changing the cell this 35, 32. It has changed. So corresponding to 48, we know that it is 37.42.
Understood, sir. Yes, sir. Thank you, sir.
Yeah.
Sir, instead of making the humidity charts, can we just write a program in which we have to just put any two values of the five and we can get the
Absolutely.
answer?
You can use a Python code also.
Okay, sir.
The reason I'm doing it in Excel and making you do the chart is because I'm going to show you what an actual humidity chart looks like. So this is how the actual humidity chart is plotted. Okay, can we go forward? Anybody still doing? Can we go forward? Prajot, Prajot Patil, can we go forward? Are you doing in Excel?
No, sir.
You're not doing in Excel, you're using mobile.
Yes, sir.
But later on, will you be able to do in Excel?
Yes, sir. Yes, sir.
Okay. Nakshatra, are you with us? Are you doing calculations in Excel?
No, sir, I have connected from mobile.
Okay, will you do it later?
Yes, sir.
Craig, Craig D'Souza, are you there?
Yes, sir.
So are you doing in Excel?
No, sir. I will also do it after the lecture.
Okay. Bhakti,
Yes, sir.
are you doing in Excel?
No, sir. I'm having mobile, so I can't do it.
Do it later.
Yes, sir.
Okay, so the advantage of this chart, if we have got now we have got a graph that relates humidity on the y-axis to temperature on the x-axis with different percent RH values. So percent RH is say 80, percent RH is, so in this one corresponds to 80, this red line corresponds to 90, this blue line corresponds to 100, this yellow line corresponds to 50, this blue line corresponds to 30, this green line corresponds to 10% RH, right? So the advantage is we don't have to do these calculations again and again and again. Suppose I say temperature is, let's say 22 degrees centigrade and percent RH is 50. All I have to do is go to 20% RH, go to 50% RH, 20 degrees centigrade, 50% RH. That means we are talking about this particular point. I can immediately get the humidity looking at this humidity chart, and I can immediately get the dew point. Dew point will be when this humidity, when this vapor pressure becomes, partial pressure becomes equal to vapor pressure. So at this humidity, I just have to go to the chart corresponding. So let me just explain. One second, let me just explain. Yeah. Here it is. Suppose I say we are having 30 degrees centigrade temperature and 80% humidity. That means we are on somewhere along this line, and 80% RH. That means we are here. We are at this point. Do you agree with that? All I have to do is look at the graph, and from the y-axis I will know the humidity. Is that right? And now if I want the dew point temperature, I will just straight away go to the 100% RH line. That means at this humidity, where is it cutting the 100% RH line? It is cutting the 100% RH line here. That means at this particular temperature, the vapor partial pressure must be equal to vapor pressure at this particular temperature. So the corresponding dew point is 26 degrees centigrade. Do you agree with this? Do you realize how advantageous it is? Yes or no?
Yes, sir.
Yes, sir.
So suppose I say that the dew point is 18 degrees centigrade. So that means we are corresponding to 18 degrees centigrade. We are somewhere along this line. So our point is here. So that means we are at this particular point, 100% RH and 18 degrees centigrade. So suppose I say dew point is 18 degrees centigrade and percent RH is 50 degrees centigrade. Right now, what do? I know the dew point is 18 degrees centigrade, so I know that humidity must be corresponding to the vapor pressure, that is the 100% RH line at 18 degrees centigrade. But now my percent RH is not 100, percent RH is 15. Right? That means I just have to go across to the 15 degrees centigrade line, and I just have to and I just have to calculate. I just have to note down, or I just have to see the point of intersection. That means I am here. Right? And then correspondingly, if I want what is the dry bulb temperature or what is the temperature of the air, I will just have to go down and read from this graph. Right? We'll find something like 30.5 degrees centigrade. Right? Do you see how advantageous it is to use this graph? Yes or no?
Yes, sir.
Only thing is now we have plotted this graph corresponding to 760 mm Hg. Suppose I want to plot this graph for 750 mm Hg or 735 mm Hg. All I have to do is change in this cell, and then everything will automatically change. You see that? Everything has changed automatically. That's the advantage of doing it in Excel or writing your own Python code. Suppose pressure is not 735, pressure is 800. All these values will automatically change. Okay, now let's go forward. Can we go forward?
Yes, sir.
Okay, anybody still doing calculations? Now what I want to do is on this chart, I would like to plot the wet bulb temperature relationship as well. All right. I would like to plot the wet bulb temperature relationship as well. So suppose I say that the wet bulb temperature is 20 degrees centigrade. Okay. Let me just write that. So let me say that wet bulb temperature is 20 degrees centigrade. Okay. Now, corresponding to 20 degrees centigrade, can you tell me where the point would be corresponding to the wet bulb temperature of 20 degrees centigrade and HWB. Can you tell me where the point would be corresponding to the 20 degrees centigrade and corresponding humidity at the wet bulb temperature 20 degrees centigrade and the corresponding humidity at the wet bulb? Can you tell me where that point would be? How will I get this? How will I get corresponding to 20 degrees centigrade humidity? I'll have to convert to vapor pressure, convert to humidity. Haven't we done that?
Yes, sir.
Where would that point be?
So 100% RH.
100%
Correct. That
RH
point
line.
would be somewhere along this 20 degrees centigrade line, but corresponding to 100%. That's how our HWB is, right? So this is our point corresponding to TWB on the x-axis and HWB on the y-axis. Do you agree with that? Yes or no?
Yes, sir.
Now, if I plot points corresponding to constant wet bulb temperature of 20 degrees centigrade, that means which equation we are solving? The equation that we are solving, what is the equation that we are solving? We are solving the equation, let me get rid of this, HWB minus H is equal to, right, so 0.24 plus H times 0.45 divided by lambda WB multiplied by T minus TWB. Okay, let me just go back to my my notebook. I think it is better to explain in the notebook. Right. Suppose I want, suppose I say TWB is 20 degrees centigrade. Right. Correspondingly, I would calculate the HWB, and that point would be here, corresponding to 20 degrees centigrade. This point, what will be the coordinates of this point? It will be 20 and the corresponding HWB. TWB equal to 20 and HWB, corresponding HWB, and the corresponding HWB is here because it is at 100% RH. Right now, what is our equation for the wet bulb? HWB minus H is equal to 0.24 plus H times 0.45 divided by 540 plus 0.55, 100 minus T wet bulb, T minus T wet bulb. Right, this equation, suppose I want to plot this equation on this graph, right? So what I will do is I will take different values of temperature, right? So HWB is known, TWB is known, 20 degrees centigrade, corresponding the HWB we know, correspondingly lambda we know, this we know, this we know. We have a relationship between T and H. Do you agree that this relationship between T and H will be corresponding to 20 degrees centigrade wet bulb temperature? Do you agree with that?
Yes, sir.
Somebody say something. Somebody say something. Forget
Yes,
all.
sir.
Yes, sir.
Forget forget all this. I think only one or two people are following. Suppose I say TWB is 20 degrees centigrade. Calculate vapor pressure at the wet bulb temperature. Calculate the humidity at the wet bulb condition corresponding to total pressure of 760. Somebody calculate. Somebody calculate and tell me.
So
So sir,
17.184
17 point.
184 mmHg and humidity is 0.0146.
17.184 and humidity is 0.
146, sir.
146.
146. Now, if I plot in this relationship, if I plot it here, if I put it in this equation, if I put these values in this equation, HWB is 0.0146, TWB is 20, TWB is 20. Don't I have a relationship between H and T?
Yes, sir.
Yes, sir.
This relationship between H and T, this relationship is corresponding to wet bulb temperature of 20 degrees centigrade. Are you with me? Is that okay?
Yes, sir.
Yes, sir.
So take different values of temperature. Let's say temperature we take as 21, temperature we take as 22, temperature we take as 23, temperature we take as 24. Hypothetically, just do this hypothetically. Temperature equal to 25. Use this equation and calculate H. Use this equation corresponding to temperature of 22 degrees centigrade and calculate H. Use this relationship at temperature 23 and calculate H. Use this relationship and calculate H. Use this relationship and calculate H. How will it look like? If temperature goes up, what's going to happen to humidity? And I want you to plot these points.
The humidity will decrease.
Yes, yes, humidity will decrease. Calculate. Calculate and plot these points on this graph. Calculate temperature of 21. What is the humidity? Somebody tell me values. Somebody calculate.
Sir, calculating, sir.
Any one value you got? Just a linear equation. For any temperature, it is just a linear equation between linear equation for H for any temperature. What takes so long?
Sir, up to how many decimal points?
27.
Sir.
So for 21 degrees, it would be 0.0145 8.
You're not telling me up to 27 decimal points. You're only telling me up to 4 or 5 significant figures. Anirudh, the next answer 27 decimal points.
Sir, no, sir. I was doing it on Excel, so I was asking the decimal point. It came to more than required.
So you round it off and tell me, no?
Okay, sir.
Sir, it's not 5.8, it's 1.7. Sorry for this.
Anirudh, the 22 degrees centigrade.
Sir, I'm getting point not 165.
How it can be higher than HWB?
Sir, 1375.
I extended the previous.
How it can be more than Anirudh, how it can be more than HWB?
Yes, sir. I
So the next
extended the
one,
previous one.
0.0133.
That is corresponding to 23 degrees centigrade.
Yes, sir.
Okay. Anirudh, check your values. How it can be more than 0.0146?
Yes, sir. Yes, I made a mistake in the formula.
24 and 25.
Sir, at 24 it is 0.0129.
It's linear, right? Almost linear. It is linear.
So for 25, 125.
Yeah. Now, if I plot these points on this graph, how will they look like? They will look something like this. They will start with this point. They will start here, and that straight line will look something like this. These points, if I plot. So all this red line corresponds to a wet bulb temperature of 20 degrees centigrade. Similarly, I can take wet bulb temperature of 15 degrees centigrade. HWB would be here. This point would be, this point would be, this point would be 15 degrees centigrade, and the corresponding HWB at 15 degrees centigrade. Again, I can use this expression. Only thing is now I will take this as 15 degrees centigrade. I will take this as 15 degrees centigrade, and I will take this HWB at 15 degrees centigrade. And again, I will take different values of T and I will calculate H and plot that graph. That graph would look something like this. This would have, all these red line would have a wet bulb temperature of 15 degrees centigrade. I can do it for wet bulb temperature of 30 degrees centigrade. So 30 degrees centigrade is here. 30 degrees centigrade is here. This point would correspond to 30 degrees centigrade and the corresponding HWB. Now I can put this instead of 30 to 20, 15, now it is 30. This is also 30. Now this also is at HWB now is at 30 degrees centigrade. So I can take this equation, find out, take different values of T and find out the values of H and plot that graph, plot that straight line. That would be this straight line, it would have wet bulb temperature of 30 degrees centigrade. Same way I can do it for 25 degrees centigrade. This will be corresponding to wet bulb temperature of 25 degrees centigrade. This line would be corresponding to wet bulb temperature of 10 degrees centigrade. So you can do this in Excel. You can plot this in Excel. So the advantage now is if I tell you the temperature, let's say I tell you the temperature is 25 degrees centigrade and wet bulb temperature is 20 degrees centigrade. Right? That means corresponding to 25 degrees centigrade, if I go up, wherever it cuts the 25 degrees centigrade line of wet bulb, that means this is where we are. That's our point corresponding to 25 degrees centigrade dry bulb temperature and wet bulb temperature of 20 degrees centigrade. Now I can get the humidity straight away by just reading from the graph. And I can get the dew point straight away from the corresponding 100% RH. This would be the dew point. Okay. So I give you any two out of the any two parameters. Suppose I say that my temperature is 30 degrees centigrade, dry bulb temperature is 30 degrees centigrade, and I have 50% RH. So corresponding to 30 degrees centigrade, if I go to this 50% RH line, that means we are somewhere here. So the dew point must be corresponding to this wet bulb temperature line, 25 degrees centigrade. Obviously, this is not an accurate graph because we have just plotted it at random. I want you to do it in Excel. Do it in Excel now. Do it in Excel. Plot the wet bulb temperature lines. Okay, will you do this later? Will you do it in Excel later? Let us just go to the chart. So what you will get is a humidity chart. I'm just showing you one example of this chart. Okay, so it has dry bulb temperature on the x-axis. It has all these percent RH values here. Are you able to see? 90% RH, 80% RH, 70% RH,
Yes, sir.
60% RH, and so on. Right, all these RH are there. Let me open this in 1 second. Let me open this in my Explorer. It will be better seen, and I can comment also. Yes, are you able to see? So it has temperature.
No, sir. The screen is
Yes,
not
sir.
presenting.
You're not able to see. It is presenting. Yeah, now you're able to see.
Yes, sir.
Yes, sir.
Okay, so what this is the humidity chart. You can construct that in Excel all by yourself. So what it is plotting is temperature on the x-axis, right? Dry bulb temperature on the x-axis. It is in terms of degrees centigrade. So 20 degrees centigrade, 30 degrees centigrade, 40 degrees centigrade, 50 and 60 and so on. On this side, y-axis is our humidity, right? In terms of moisture content, in terms of kgs of water vapor per kg of dry air. You see that? Okay. All these lines are corresponding to different RH. So this is obviously corresponding to 100% RH. This line corresponds to 90% RH. This corresponds to 80% RH, 70% RH, 60% RH, 50% RH, 40% RH, 30% RH, 20% RH, sorry, 25% RH, 20% RH. Then this is 10% RH. This is 15% RH, 9% RH, and so on. 8, 7, 6, 5, 4, 3, 2, 1% RH. Are you able to see properly? These lines are corresponding to the wet bulb temperature. These lines are corresponding to the wet bulb temperature. So this line corresponds to wet bulb temperature of 35 degrees centigrade. This line corresponds to wet bulb temperature of 30 degrees centigrade. This corresponds to 31 degrees centigrade. This corresponds to 32 degrees centigrade, 33 degrees centigrade, wet bulb temperature, 34 degrees centigrade, wet bulb temperature, 20 degrees centigrade, wet bulb temperature, 21 degrees centigrade, wet bulb, 22 degrees, 23 degrees, 24 degrees wet bulb temperature, 25 degrees wet bulb temperature. You see, it is written here, wet bulb temperature. 36 degrees wet bulb temperature, 37 degrees wet bulb temperature, 38 degrees wet bulb temperature. So now if I say that my air temperature is 40 degrees centigrade and I have, let's say, 10% RH. So we go from here, or maybe 30% RH, let's take. So we go up from here, go to 30% RH line. This is 10% RH. This is 15% RH. This is 25% RH. This must be 30% RH. Where is that? Yeah, 30% RH is somewhere here. Yes. So this is our 30% RH. Do you see? This is our 30% RH. So if I say that dry bulb temperature is 40 degrees centigrade and 30% RH, that means we are on this point. Do you agree? Yes or no?
Yes, sir.
If I want the
Yes, sir.
humidity,
Yes, sir.
if I want the humidity, I will just go to the y-axis and I will find out. Humidity would be 0.01, 0.02, 0.01, 0.013, 0, 0.1, 0.11, 0.12, 0.13, 0.1. Oh, sorry, it is in terms of 0.02. So this will be 0.012, 0.014, 0.016, 0.018, and 0.02. So correspondingly, humidity will be 0.014. If I want the wet bulb temperature, I just have to see which line is corresponding to this. So it corresponds to 25 degrees centigrade wet bulb temperature. This is the line corresponding to 25 degrees centigrade wet bulb temperature. Dew point, if I want, I just have to go around, go to the left and see where it intersects this axis. It is intersecting somewhere here. So maybe 19 degrees centigrade dew point. Now, if I say that dew point is, let's say, 25 degrees centigrade and dry bulb temperature is 35 degrees centigrade, right? So all I have to do is dew point is 25 degrees centigrade. That means I must be somewhere along this line. I must be somewhere, let's take another color. That means we must be somewhere along this line. If dew point is 25 degrees centigrade, that means our humidity must be somewhere along this line. So humidity is obviously 0.02. And if I said dry bulb temperature is 35 degrees centigrade, so this is 30, this is 32, this is 34, this is 35. We are corresponding to, we are at this point. So this point, if I go along this line, this is like 60% RH. This is the line corresponding to 60% RH. So if I say dew point is 25 degrees centigrade and dry bulb temperature is 35 degrees centigrade, percent RH would be 60. And wet bulb temperature, I just have to go along this line, whichever line is going through this point. It is this wet bulb temperature line is going through this point. This is 25, this is 26, and this is 27. So our wet bulb temperature must be 27 degrees centigrade. Are you able to see? So that's the advantage of using this humidity chart. They are called as psychrometric charts. They are called as psychrometric charts. Why it is not highlighting? Psychrometric chart. Okay, this is for higher temperature. There is one corresponding to lower temperatures as well. Are you able to see now? This is another chart. This is at a lower temperature. It starts with -10, goes up to 50, 55. Are you able to see this chart?
Yes, sir.
Yeah.
Yes, sir.
So now suppose I say that, let's say I say that temperature is 30 degrees centigrade and dew point is 15 degrees centigrade, right? So dew point 15 degrees centigrade, that means you'll just have to go around, go to this 15 degrees centigrade. That means our humidity must be somewhere along this line. And temperature is 30 degrees centigrade. That means we must be having this point, 30 degrees centigrade. and 15 degrees centigrade dew point. So humidity I can straight away get from here. That will be 11. 11 is in terms of grams of water vapor per gram of per kg of dryer. So you see the units, it is grams per kg. So 0.011 kg per kg. Now what is the percent RH? Well, it is going through this. 40% RH is this line. So slightly more than 40% RH, slightly it will be less than 50% RH. So maybe we'll just have to do interpolation. You can do linear interpolation. Maybe 42 degrees centigrade would be 42% would be your percent RH. Wet bulb temperature. This line is slightly below this point. This line is slightly above this point. This corresponds to a dew point or a wet bulb temperature of 20 degrees centigrade. This corresponds to a wet bulb temperature of 21 degrees centigrade. You see, these lines are all wet bulb temperature lines. Right. So dew point would be just above, wet bulb temperature would be above 20 degrees centigrade, but below 21 degrees centigrade. Right? So that's how we would use our humidity charts. But mind you, these charts are there only for a total pressure of 760 mmHg. Nothing else. Same way, this chart, this also is at a total pressure of 760 mmHg. Nothing else. If you have to go to any other pressure, you'll just have to create your own chart or just do the calculations in Excel. Right. So let me share the notebook once again. All right. Everybody okay? Comfortable so far? So homework. Construct your own humidity chart. Corresponding to different total pressures, say 740, 720, 760, 780. Okay, compare with available charts. Okay. Second, all the problems that we did so far do with humidity chart. Meaning these four problems that we did, do them with the humidity chart. Okay. Are you able to see these four problems that we did last time?
Yes, sir.
Yes, sir.
Do them with the humidity chart. Next is this problem that we did. Was the total pressure 760? Yeah, total pressure was 760. Fortunately, total pressure was 760. So do this with humidity chart. Okay, do this problem with humidity chart. All the other problems that we have done so far, dryer problem, milk dryer problem, right? Here also we said total pressure. Oh, total pressure was 740. So suppose you make total pressure was 760, then you can use the existing humidity chart. Okay, do this problem also with the humidity charts. So you can do these problems with humidity charts. Existing available is at a total pressure of 760, but you can generate your own humidity chart at any other pressure and do these problems, all these problems that we have done so far. Okay, shall we stop for the day?
Okay, sir.
Any quick question?